Hello, 122. I was asked to do some homework questions, so I'm gonna do them. How's it going? Assignment. Hey, remember, if you have any homework questions, you can ask me to do them. I'm looking at 5.321. Yeah, show me. 5.3. There we go. 5.3, number 21 is this mess. Let's copy this. We're given this function, and we want to work out some integrals. We want the integral from 0 to 6. So that's, let's use purple, that's this area, right? Actually, it's not this area, it's the area above the x-axis. That messes this up. This is where the x-axis is. So I want what's the area below the x-axis and above, or below the curve and above this x-axis. Or if the thing goes below the x-axis, this area also counts, but it counts negative. So I'm looking for what is this area plus this area but negative. Okay, so I got a square. This is 3, at least in my version of the problem. It's a 3 by 3 square. This area is 9. What's this area? Well, it's half base times height, and I could work that out. But this triangle is the exact same shape as this triangle. Like, it's cutting through it exactly half, same base, same height. And one counts positive and one counts negative. So, whatever that area is, and we could work it out, but it cancels itself out. I'm getting this is exactly 9. Cool. How about this one? The integral from 9 to 21. What's going on here? There's 9, there's 21, so I'm looking for 9 to 21 is this area. Well, that's a half circle. If it wasn't clear, that's a circle. What's the area of a circle? The area of a circle is pi r squared. Is this actually a circle? Is that radius the same? This is from 0 to 6 is 6. And this is from halfway between 12 and 18 is 15 to 21 is also 6. So yeah, it's the same radius. So yeah, it looks like it's a circle. If the scaling was weird, it would turn out to be an ellipse, not a circle. This one is a circle. The area is pi r squared. The area of the whole circle would be pi r squared. It's pi times, we just said the radius was 6 squared is 36 pi. We don't want the whole circle, we want half circle. So the area of that is going to be 18 pi. What's up with C? C says, what's the integral from 6 to 21? Six to 21 is that, but throwing in this, I got this triangle. It's half of a 3 by 3 square, so its area is 4.5 or 9 halves, and it counts as negative. So the integral from 6 to 21 is this half circle, which we just said was 18 pi, minus this half square is 9 halves. There's that area, or that integral. And then D wants what's the integral from 15 to 24. 15 to 24. Ooh, that's a weird shaped one. This time I have a quarter of the circle. Half the circle was 18 pi, quarter of the circle will be 9 pi. And then I want all of this stuff to count negative. I can set this up like a trapezoid. It looks like this is supposed to be at halfway between 21 and 24. So this will be 22.5. There's a formula for the area of a trapezoid, but that seems dumb. I guess I'm just going to treat this like a square and a rectangle and a triangle, because I know that one. The triangle is 1.5 by, how tall is that? From 0 to 6 is 6. 1.5 times 6 is 9. I only want half of that, so this is going to be 4.5 is this area. Whereas this is a 9 by 6 by 1.5 rectangle. This will be a full 9. 9 and 4.5 is 13.5. I'm getting the area of this whole mess is 13.5, and it should count negative. So D, the integral from 15 to 24, will be 9 pi minus 13.5, that's 27 halves. Yeah, that's it. Let's try typing these in and see if we got it right. What's this one supposed to be? It's supposed to be 18 pi Now I need a pi. You got the symbols? There's that pi. What was this one supposed to be? It was 18 pi minus 9 halves. Ooh, can I copy? No, I cannot. Minus 9 over 2. And what was this one? This one was 9 pi minus 27 halves. Pi minus 27 halves. Did I get it? Hooray! My answer is correct. Next up. Next up was 5.3, number 18. Part A is weird and kind of irrelevant to calculus. Select the correct graph of x plus 3, x minus 2. That thing is factored. I guess I can stick it in a calculator and see what it looks like, but it's factored, and the distinguishing feature of the graphs they're showing me is they have different x-intercepts. If I ask when this thing equals 0, that's at x equals 0, or at x plus 3 equals 0, which is x equals negative 3, or at x minus 2 equals 0, so x equals 2. I'm looking for a graph that hits the x-axis at 0, and at 2, and at negative 3. And I don't know if it's like this or like this. I could figure that out, but I think this is enough to tell the things apart. Like this is 2, negative 4, it's not that. 1, negative 2, no. 1, negative 3, no. 3, negative 5, no. 2, negative 3, there's the one. This is the one that's the correct graph. So it looks like this. We got a bigger hump here and a smaller hump here. What's up next? Find the total area between the graph and the x-axis between negative 3 and 2, and contrast that with the next problem, which is going to ask what's the integral from negative 3 to 2. Well, the integral from negative 3 to 2 is the more straightforward one. That's the one we just asked our calculator to do. I say, hey, calculator, let's graph this function. It's x times x plus 3 times x minus 2 let's go to standard zoom so I can see what's going on. Actually, let's tell it to graph it from -3 to 4. I like going a little past the points we care about. Oh wait, I meant to say -4 to 3. And also it looks like it's way off the scale on the y-axis. Let's make that -5 to 5. Can we see anything if we go that far? Yeah, we're still going way off, but that's good enough. Alright, I want the integral. Second trace is calculate. 7 is integral. Calculate the integral from -3 to 2. All that positive area and all this negative area is going to be 10.4166. When we do this, this area counts as positive and this area counts as negative. So the definite integral, you want to describe it as the area under the curve, but there's a big asterisk on that, that it's the area under the curve minus the area above the curve and below the x-axis or something like that. There's not a really good slick way of describing what's going on here. What was this? This was 10 point. 41667. Show me 10.41667. How do I know what's the area between the graph and the x-axis? That's the oversimplified explanation that doesn't account for the fact that some of this counts as negative. When you ask for the integral, I want this to count as negative. They're not asking for the integral in part B, they're asking what is the total area. So I find this area, and I find this area as separate integrals. When I just integrate from -3 to 2, it smushes the positives and the negatives together. We want to, by hand, go back and say, no, don't make that part negative. We're going to work out the integral from -3 to 0, and the integral from 0 to 2. And this one's going to come out negative, and we're going to change it to make it positive, because when someone says find the total area, and they don't say make the negative stuff count negative, then you don't want it to count negative. Where'd I put my calculator? I'm going to change the window so it stops shading all that stuff. I want a version that's not shaded, so that when it shades it for the next integral, calculate the integral from -3 to 0. This one is 15.75. So that area is 15.75. And when I ask it for what's the integral from 0 to 2, it gets -5.33. So that area is 5.33. If I add those up, that'll be, oh, I can almost do that in my head. 21.08. So this integral is negative, the area is positive, I add those together and get 21.08333. Did I got it? Hooray! I did got it. And then the last problem was from 4.5. Yeah, 4.5, question 2. We're looking at a graph, we want to read average cost. Average cost is total cost divided by quantity. So I want to know my quantity is 10,000. And this amount is how much? These are the most annoying tick marks in the world. They've labeled it so that every 4 tick marks is 5,000. So every single tick mark is 5,000 over 4 is 1250 per tick mark. How many tick marks high is this point? It looks like we're at 4, 5, 6.5. What do I get when I multiply those? This is 6.5 times 1250 is, I'm getting 8125. Divide that by 10,000, that's 0.8125 is my estimate for the average cost. Yeah, sure, whatever. Yeah, okay. This is 0.8125, which is the cost of each unit on average of all those 10,000 units. Each unit's share of the total cost of, yeah, they cost this much each on average. Select the correct graph of your answer to part A. Okay, so this is also a slope. It's the rise over run if I draw a line from 0, 0 to that point. Here's the one that goes from 0, 0 to that point. I think these are a bunch of lines that go from that point to different places, yeah. At approximately what production level is average cost minimized? Here's the thing where... Oh, I never copied this, did I? Or, I guess if I did, I lost it. Let me copy this graph. So, if I hold up a ruler here to here, the average cost is this slope, right? I'm supposed to be going through this point. It's the slope that goes from here to that point. I can ask about lots of points and say, hey, what is the slope from here to there? What is the slope from here to there? What is the slope from here to there? The minimizing one will be how low can I, if I'm fixing one part of my ruler here, how low can I tilt my ruler and still touch the graph at all? If I can get this... That is the lowest one where I tilt the graph. If I hold one end of the ruler here and then tilt it as far down as I can go and still touch the graph, when I reach this point, that's the lowest I can go. It's just bouncing off the graph here. So that is the lowest average. Let's see. This Q value is the Q value that minimizes our average cost. What is this Q value? 1, 2, 3, 4, 5 tick marks was 10,000. So each tick mark is 2,000, 12, 14, 16, 18,000 is the Q value for minimizing average cost. What is the minimum average cost? I would need to again take the C value divided by the Q value. Did they ask us for that? Oh, they're just asking at what production level is average cost minimized. I'm getting 18,000 there. Submit. Cool. Cool. That's some homework questions. If you got more homework questions, you're always welcome to ask them. Some of them are easy enough to answer by text, or I can make a video if it's not. Yeah, see ya. Or I won't see you, because we're never gonna meet each other. I mean, we might meet each other, so stop talking now.